Hello guys, good evening.
Good evening, sir.
Good evening.
Good evening, sir.
Good evening. दिव्यानी नहीं आ रही क्या क्लास में?
Don't know,
Ari
sir.
is here.
श्रुति, अनन्या. Ananya, will you be able to? Yeah. Okay. So you're not in a car. Okay, all right.
So my plan got
Sorry.
shifted. So the plan got shifted. That's why.
Okay, that's great for us. So
Wait, she was going in a car. So
yeah,
what?
she told me that she'll be in a car, so she'll connect from a car.
I
Won't be able to
thought.
participate much. That's okay. Uh, let's start. ठीक है. So आज we will be starting with natural exponential, and we'll be completing the chapter today. And after that, next class we'll be taking some problems and starting with the new chapter, logarithms. Okay. So do you have any doubts in the chapter till now?
I didn't practice
Why?
because I haven't been that well, but like now I've recovered kind of. So I'll start
You're
practicing.
feeling well now?
Yes, sir, kind of. I mean, it's quite weird. The the COVID is quite bad. I mean,
What happened? Like
so it's
what
quite
are the,
unpredictable
what are you
in the
not?
sense one time like one moment I'm doing fine. I mean right now even I'm doing fine. Then as soon as the evening comes and my body starts aching and stuff, even though it's been like more than 14 days now.
Right, right. So you are not feeling energetic enough.
Yeah, so there's a lot of weakness even though we're eating a lot, but I don't know. So yeah.
Hmm.
Seriously, so I mean I don't even feel like studying when it's like that. So I haven't studied still yet. But I'll start math now.
Yeah, keep doing something. Keep yourself engaged in something. Okay.
Yes, sir.
Whenever you get the time, do some practice so that you do not forget what we are doing in the class. Okay. Also, see the earlier videos that you missed whenever you get the time. Okay, and practice for those as well. All right. Okay. Ananya, do you have any doubts?
So I didn't practice. So I was traveling.
Where are you traveling to?
No, sir. I was traveling over the weekend, so I couldn't do it.
She's in Punjab.
Oh, okay. All right. So practice, man. You do not want to miss practicing, otherwise it will be stressful later on. I've already told you that. Do not do it do not keep it for the last moment. Keep practicing as soon as you get the time, and find time for doing this. Okay. All right. So today we'll be doing natural exponential. So natural exponential. Natural exponential doesn't have that much that we need to understand clearly, but it is the continuous compound interest that we'll be doing in a bit of detail. Okay, which you have as an investigation, and I think you get investigations also in exams, so it is quite important that we do this. Okay, so first I'll tell you what natural exponential is, then you'll tell me what continuous compound interval is. Okay, and how do we get the formula for that? So natural exponential is when we are using the base as e in in place of a. When we are using the base as e, okay, then it is known as a natural exponential. That is, the function becomes y is equal to e to the power x. The function is this. Then we say that it is a natural exponential. So base is an e. Base is e. E is an irrational number. Irrational number which is approximately equal to 2.718. Approximate value is 2.718. Of course, it is an irrational number, so we are not able to find the exact value, but the actual value of E is equal to 1 upon factorial 0 plus 1 upon factorial 1 plus 1 upon factorial 2 plus 1 upon factorial 3 and so on till infinity. If we keep going like this is the actual value of E. Okay? E is an irrational number. It is a constant which is approximately equal to 2.718. Okay, and it is like pi. जैसे pi एक constant है, it is an irrational number. Just like that, we have another number which is E. Okay, now यहाँ पे this is the actual value of E. You know what factorial stands for. So factorial n, which you have done in previous classes, is the product of first n natural numbers. So factorial n is equal to 1 into 2 into 3 into 4 up till n. This is the value of factorial n, and
Sorry, nothing.
and factorial 0 is equal to 1. Correct? You know all this. You have done this in previous classes. Okay, this is the value of E. This is the approximate value of E. When we use the base as E, then it is known as natural exponential. We also use E in logarithms. So we have already done this in 10th. So log x to the base E is known as ln x, or it is written as ln x. You have to leave at 6:15. Okay. I
So
think we
can
will
you
be able
end
to.
the class early today? Because today's CSK's match, and I'm really panicked about that. And
You have what?
so today's CSK's match, and I'm really panicked and stressed. And I won't be able to continue after 6:15. So can we end the class at 6:15 today?
I think, yeah, we will be able to do it by 6:15. So I'll try to end the chapter by 6:15. Okay.
Okay, seriously,
So
that sounds cool. I was
please,
just
please also
interrupting you
clear.
to saying
Don't
that
mind.
only.
Huh?
पहले भी I was interrupting you to say that only. Can we interrupt the class?
Okay.
Can we leave it?
All right. All right. I'll leave you earlier. Okay. 15 minutes earlier. So log of x to the base E is written as ln x, and it is known as natural exponential. Natural logarithm. I'm sorry, natural logarithm. So natural log hota hai when the base in the logarithm is E. In exponential, it is e to the power x. ठीक है? This is all we have in natural exponential. इसके बाद ये समझ में आ गया ना? Okay. Now coming to continuous compound interest. Is the lighting better today or is it the same?
It's always been good, quite
So
decent.
it's been the same?
Yeah.
Okay.
Doesn't हो सकता है ऐसा change है. I mean, I don't really see the difference. I mean,
Yeah, all right.
didn't really notice.
Okay. We were just trying different places for the light. It's okay if it's the same. Continuous compound interest. Okay. Continuous compound interest क्या होता है? Let's see that. उससे पहले, first we understand what compound interest is. Do you know what compound interest is? How can you explain compound interest if you have to in your words?
When you invest money, I mean, what? I don't know. I can't explain.
No,
it.
can't. Simple interest and compound interest. Okay? There are two types of interest. So the difference is that in compound interest, we pay interest on interest as well. Okay? Whereas in simple interest, we just pay interest on the principal amount. Okay? Let's understand with an example. For example, if I have rupees 200, sorry 100, and 10% interest rate per year, per annum लिखते हैं, PA means per annum, which is per year. Then under simple interest, or if the interest is being paid nahi, if I'm paying simple interest or I'm getting simple interest on this, then after 1 year, my total amount will be equal to 100 plus 10% of 100, which is equal to 110. After second year, I will get 110 plus 10% of 100, which is equal to 120 rupees, correct? This is simple interest. I am getting interest on the principal only. Whereas in compound interest, what is happening? In the first year, I am getting 10% on 100, so I will be getting 110 rupees. But in second year, the interest will be on this value. Okay, I will be paying interest on, or I will be getting interest on this value. Okay, so 110 ka 10% hoga, I will be getting interest equal to 11 rupees. So after 2 years, total amount will be equal to 121 rupees in compound interest. So what is happening? I'm paying interest, or I'm getting paid, or paying or getting, same thing. Okay, not same thing. I mean, either we take money from the bank as a loan, or either we get interest from the bank on our account. Okay, so that's why paying or getting. So 10% on this value will be 11 rupees. I will be getting that much interest in second year. So the total amount will be 121 rupees. So I'm getting interest on interest as well in compound interest. Okay, this is the difference. Now, to find out the formula for compound interest, we first take U naught, which is the initial value or initial amount. I is the interest rate
So I have a
per
doubt.
compounding period.
So how is the simple interest in second year 120? Like, is shouldn't it be, I don't know. I mean,
What?
no.
Simple interest here?
Yeah. So you
I will,
mean 100 every year will be 200 and 10% of 200 is 20.
no,
So
100
you'll
is the
have,
amount we have in the account, and then I'm getting interest on that. I'm
yeah,
not
so
adding
200,
100.
so 200 for 2 years, right? And then
No,
10% interest on 200 is
principal
20.
amount is what we have deposited in the bank. We're not giving 100 rupees again after that. We're just getting interest on that amount.
So how do you get, oh, so 2 years. Okay, sorry.
It's
20% of,
not like I'm putting 100 rupees again
yeah, yeah,
every year.
okay, sorry, makes
Not
sense.
doing that.
Because 20% becomes 2 years. Okay.
20?
In the sense 20% हो गया ना 2 years, so it'll be, so I'll add 20 to 100. Okay, I got it. No, no,
20% increase. You can say
yeah,
20% increase in 2 years,
yeah,
whereas here it is 21% increase.
yeah, oh, yeah, got it.
Yeah. So I is the interest rate per compounding period. And N is the total number of periods. Now, what are periods? Period is the time after which we are being paid, or we are paying the compound interest. Okay? For example, if I'm paying, if I'm paying it annually. Okay? Yeah, I should actually take 1 minute. If the interest is being compounded. Okay, yeah. Remove this getting paid or being paid. That is different. Let's not use that. It is confusing a bit. So if the interest is being compounded every year, okay, let's just say this. If the interest is being compounded every year, okay, then the period becomes 1 year. Okay, if the interest is being compounded every 6 months, ठीक है, तो पीरियड क्या हुआ 6 मंथ, और एक साल में पीरियड तो 6 मंथ हुआ, period is 6 months, but the number of times it is being paid is 2 times in a year. Okay, so the time after which the interest is being paid is the period. Okay, so say if we have the interest is being compounded every day, okay, so the period is 1 day, and the number of times it will be paid in 1 year will be 365 times. Understood? Okay, that is the period. Okay, total number of period is n. I is the interest rate per compounding period. It is the interest rate being paid in every compounding period, and u naught is the initial amount. Okay, then let's derive the formula for compound interest. So u1 means the final amount after one period. Okay, it will be equal to u naught plus I u naught, where I is in percentage. Okay, this will be equal to u naught into 1 plus I. U2, which is the amount after two periods, it is equal to u1 plus I into u1. Okay, for u2 the interest will be paid on u1. That is what we mean by compound interest. So this is equal to u1 into 1 plus I. यहाँ पे u1 की वैल्यू डाल देता हूं, so it will be u naught into 1 plus I to the power 2. ठीक है. Similarly, u3, which is the amount, final amount or total amount after 3 periods, it will be equal to u naught into 1 plus I whole cube. Yes.
So Divyani just messaged me that her net wasn't working, so she's trying to reconnect, like trying to connect.
All right. I'll wait. Ananya,
Yes, sir.
I thought you were reconnecting.
No, sir.
Sir, she said Divyani is trying to join.
Oh, I'm sorry. I heard it wrong, I think.
Yeah, she's trying to reconnect.
She's trying to reconnect. All right.
Yeah.
So,
Okay.
so she said that you can continue. She'll take some time.
All right. Okay. So where were we? U3. This is the amount after 3 periods. This is equal to u naught into 1 plus I to the power 3. So if we generalize this by looking at the pattern, okay, if we generalize this, then we get un, which is the amount after n periods. This is equal to u naught into 1 plus I to the power n. Right? This is the formula for compound interest. Un, which is the final amount after n periods, this is equal to u naught into 1 plus I to the power n, where I is the interest rate per compounding period and n is the total number of periods. Yes, clear? Okay. So this is the formula for compound period. But usually what happens, usually we are given the interest rate per year, right? यहाँ पे अपन ने जो I use किया है, that is interest rate per compounding period, but usually we are given the interest rate per year. ठीक है? Yearly अपन को given होता है interest rate. So let's take R as the interest rate per year and T as the number of years.
So if it's given, if it's compounded every day, so n will be 365 or n will be 1, like if it's done every day in a year.
N is the n, we do not know what n will be. If we have
So
to
I'm giving
find,
an example, no?
yeah,
So if it's compounded on a daily basis in a period of 1 year, so n will be 365.
n will be 365 if we are taking the amount after 1 year. If we are,
After every day.
if it is being compounded every day and we want to know the amount after 1 year,
1 year,
then
yeah.
365.
Then
If we
yeah.
want to find the amount after 2 days, then n will be equal to 2.
Oh, okay.
Okay, so 365
Oh,
only when we find the amount after 1 year,
okay.
after 365 days.
Oh, wait. So if it's compounded every day, but I only want to find it for half a year, so my n will be 365 divided by 2, right?
Yes, yes.
Okay. Thank you.
Okay, so if interest rate, r is the interest rate per year, t is the number of years, and capital N is the number of times interest is being compounded in a year. Okay, so then we can change the formula and write it in terms of r. Then we can change this formula and write it in terms of r. How? We see that I is equal to r by n, where I is the interest rate per compounding period, r is the interest rate per year.
I didn't know that I is equals to R by N. That's a formula.
आई एम ट्राइंग टू डिराइव द फॉर्मूला.
Oh,
ठीक है,
okay.
वही तो मैं बता रहा हूँ, तो उसको समझ तो सही. आई इज द इंटरेस्ट रेट पर कंपाउंडिंग पीरियड, आर इज द इंटरेस्ट रेट इन 1 year. ठीक है, एंड कैपिटल एन इज द नंबर ऑफ टाइम्स इंटरेस्ट इज बीइंग कंपाउंडेड इन अ ईयर. So we will get I is equal to R by N. For example, suppose um, suppose rate of interest is 6% per annum per year. ठीक है, and the interest is being compounded. First, interest is being compounded every year. ठीक है, in this case, I will be equal to 6/1 because n, which is capital N, it will be equal to what? It will be equal to 1 because in 1 year only one time the interest is being paid. ठीक है, because it is being compounded every year. So I will be equal to 6% in this case. But if the interest is being compounded every 6 months, every 6 months, then I will be equal to 6/2 because capital N will be equal to 2 because now in 1 year the interest is being paid 2 times. ठीक है, so interest in one period will be equal to 6/2. करेक्ट, 6 महीने में 6% पे करेंगे, 6 महीने में 3% पे करेंगे, तभी तो ईयरली इट विल बी 6%. क्या ये समझ में आ रहा है? Okay, so tell me this, that if the interest is being compounded every uh, every month, then I will be equal to what?
0.5. 0.5.
पहले यहाँ पे बता कितना आएगा. I will be equal to
12.
6/12.
6/12. Yeah.
6/12, which will be equal to 0.5%. Correct? So I is the amount, or it is the interest being interest rate per compound period. ठीक है? Then I will be equal to R by N. If, and we will get N, which is equal to the total number of periods, it will be equal to capital N into T. The number of periods in 1 year will be equal to N into T. Yes or no? Or total number of period will be equal to N into T. So suppose the interest is being compounded annually, which is one time in 1 year, N will be equal to 1 into T. So N will be equal to T.
Yeah.
Okay? If it is being compounded every day, then capital N will be equal to 365 and small n will be equal to 365 into t. ठीक है, क्योंकि number of periods कितने हो गए 365 into t, where t is the number of years. So in 1 year the number of periods will be 365. In 2 years the number of periods will be 2 into 365 and so on. ठीक है, so if the interest is being compounded every hour, then how much will n be equal to, or what will be n equal to if it is being compounded?
So will it be 24 into 365t?
Yes, correct, एकदम सही है. Then n will be equal to 24 into 365 into t, because 24 into 365 will be the total number of hours in 1 year. ठीक है, so when we know this and this, we can write the formula which we had derived earlier. Un is equal to u naught into 1 plus I था, तो I की जगह r by n, capital N, to the power small n, which is equal to capital N into t. This will be the formula for compound interest when rate of interest is given per year. ठीक है, आगे समझ में है? Yes, is everything clear? श्रुति, थोड़ा सा डाउट दिख रहा है मुझे, समझ में नहीं आया क्या?
नहीं सॉरी नहीं ऐसा कुछ नहीं है.
अच्छा, you were not present in the class?
No, I was
और सोच रही थी?
नहीं sir, I'm present in the class.
Okay, ठीक है.
No.
So un, which is equal to u naught into 1 plus r upon n to the power nt. ठीक है, this is the compound interest when the rate is given, interest rate is per year. ठीक है, now आगे प्रोसीड करते हैं इसमें. Let's take a equal to capital N upon r. ठीक है, अभी मैं ये कंपाउंड इंटरेस्ट का फॉर्मूला आया है. नाउ वी आर मूविंग ऑन टू कंटिन्यूअस कंपाउंड इंटरेस्ट. ठीक है, कंटिन्यूअस कंपाउंड इंटरेस्ट, व्हाट डज इट मीन? इट मीन्स दैट द इंटरेस्ट इज बीइंग पेड कंटिन्यूअसली. इट इज बीइंग पेड एट एवरी मोमेंट. ठीक है, इट्स नॉट लाइक इट इज बीइंग पेड एवरी सेकेंड और एवरी मिनट और एवरी आवर. It is being paid as soon as, or it is being paid instantaneously. After every moment we are being paid interest. ठीक है, so that means continuous compound interest के लिए अपन निकाल रहे हैं formula. So let a be equal to n by r. Then what does this formula become? We can rewrite this formula as un, which is the final amount, is equal to u naught, initial amount, into 1 plus r by n है, a is n by r, so this will be equal to 1 by a, reciprocal of this, to the power, यहाँ पे nt था, यहाँ से n की वैल्यू लिख देते हैं a into r, so a r t. ठीक है, this is equal to u naught into 1 plus 1 by a to the power a, और इसको मैंने ऐसे लिख दिया to the power whole to the power r into t. Yes, we can do this. All right, now यहाँ से we start. What is happening? If we see that if we increase the value of a, if we increase the value of a, or at very large values of a, the value of this expression 1 plus 1 by a to the power a, it becomes approximately equal to 2.718 for large values of a. ठीक है, now you have to do this exercise. Try doing it using your calculator. श्रुति, है ना तेरे पास calculator? Why not?
क्योंकि
Very bad, Shruti.
एक second, no, because I can't go downstairs and I don't have it.
I'm carrying my calculator.
Okay.
Sure, I can't go to my room. That's not my problem. Like I can't.
अच्छा, ठीक है. One is enough. Okay. We just have to verify what is happening. So Ananya, you just have to calculate these values. When a is equal to 10, then you have to find the value of this expression and tell me. ठीक है? ये तुम्हारी investigation में है. So let's fill this
So
box.
which A? Both of them are A, right?
Where a? Which one?
In the equation that you've
So,
written on the board.
yeah. So what's the problem? You have to input 10 everywhere. Okay. So 1 plus 1 upon 10 to the power 10. Tell me the value.
2.59.
Sorry, 2.59.
2.59.
2.59. Okay. Then let's skip 1 and move to 1000 when a is equal to 1000.
2.71.
2.71.
Yeah.
Okay. Let's go to the next one, which is 100,000. 100,000. Okay. Tell me till 3 decimal places this time.
Okay, so 2.718.
2.718. We are getting 2.718 when a is equal to 100,000.
100,000.
Now, find it for this is 10 million when a is equal to 10 million.
So there would be what? How much? 10 million or 1 million?
10 million. There will be 7
Seven
zeros.
zeros. Yeah.
So Divyani is here. So I'm
Hello,
sure
Divyani.
she was eating somewhere. She wasn't trying to reconnect.
Good evening,
So
sir. Sorry I'm late, sir. The network wasn't working.
Good evening. What was happening?
इंटरनेट सुबह से बहुत बार लैग हो रहा था तो वो चल नहीं रहा था and then my mobile data doesn't work very well so I couldn't do the hotspot.
Okay, so Wi-Fi is working now.
Yeah, so it's back on.
ठीक है चल.
So the answer is 2.718.
2.718 again. All right. ठीक है. So दिव्यानी को मैं थोड़ा सा बता देता हूँ. Divyani, we are doing continuous compound interest. We have done natural exponential before that. ठीक है. Natural exponential is simply when we are using the base as e. ठीक है. E is another irrational number. ठीक है. Just like pi, which is approximately equal to 2.718. ठीक है. So when we are using the base as e, it is known as natural exponential. And after that we are doing continuous compound interest, जहाँ पे अपन अभी ये वाली टेबल फिल कर रहे हैं जो बुक में है तुम्हारे. ठीक है. So what I was telling was that the value of this expression becomes approximately equal to 2.718 for large values of a. ठीक है. And we just saw that when a is equal to 100,000 it was equal to 2.718. When a was equal to 10 million, again it was approximately equal to 2.718. ठीक है. So in fact अभी तुमने लिमिट्स नहीं पढ़ा है, but in limits we have this result. Limit a tends to infinity, 1 plus 1 by a to the power a is equal to e, exactly equal to e. When a is tending towards infinity, 1 plus 1 by a to the power a is equal to e होता है, which is approximately equal to 2.718. ठीक है. So what we mean by a being very large, it means that we are making a to be close to infinity. We are taking a towards infinity. Okay? When we say that a is very large, in that case, the value of this expression is 2.718. When this happens, for very large a, meaning when a tends towards infinity, we can write the formula un is equal to this formula, or the compound interest formula, as un is equal to u naught into e to the power rt. This is the formula we get for compound interest when a is very large. ठीक है, अब a large होने का क्या मतलब है? Let's see that. क्या ये समझ में आ रहा है अभी तक? अनन्या, श्रुति?
Yes, sir.
या सो यहाँ पे ये वाला जो एक्सप्रेशन है, इसकी जगह मैंने e को रिप्लेस कर दिया है. ठीक है, and the formula becomes un is equal to u naught into e to the power rt for continuous compound interest. ठीक है, now what does it mean when a tends towards infinity? उसके लिए समझते हैं why we are getting this for continuous compound interest. यहाँ से देखते हैं from here that as n increases, as the value of n increases, the value of a also increases because n is in the numerator. So n अगर increase करेगा तो a भी increase करेगा. ठीक है, so if I am taking very large values of n, a will also be very large values of a. Sorry, a will also be very large. ठीक है, so I am taking, if I am taking very large values of n, what does it mean? ठीक है, very large values of n का क्या मतलब हुआ? Very large values of n, अभी समझो यहाँ पे, n is equal to 365 if the interest is being compounded every day. ठीक है, n will be equal to 365. n is equal to what? The number of times the n is equal to the number of times the interest is being paid in 1 year. ठीक है, so if I am getting, or if I am compounding the interest every day, n will be equal to 365. If I am compounding the interest every hour, it will be equal to 365 into 24. If I am compounding the interest every minute, it will be equal to 365 into 24 into 60. If I am compounding it every second, it will be equal to 365 into 24 into 60 into 60. And if I am compounding it every millisecond, n will be equal to 365 into 24 into 60 into 60 into 1000.
Why 1000?
Because 1 second has 1000 milliseconds.
Oh, I didn't know this conversion.
But wasn't it 100 milliseconds? Like
No, it is 1000 milliseconds. Okay, so what is happening when we are making the period smaller and smaller? ठीक है, in 1 millisecond, ठीक है, the period is very small, the value of n is increasing, it is getting larger and larger. ठीक है, so when n is very large, it means that the period is very small. So when n becomes very large, it means that I am compounding the interest in every moment. ठीक है, so when n tends towards infinity, it means that I am compounding the interest every moment. It is being compounded instantaneously. It is being compounded instantaneously. ठीक है, or we can say that I am compounding the interest continuously. Yes,
Got it, sir.
ठीक है, so when n tends towards infinity, a tends towards infinity. When n tends towards infinity, it means that I am compounding the interest continuously. ठीक है, so when a tends towards infinity, it means that the interest is being compounded continuously. So from there we get that this is the formula when interest is compounded continuously. In this formula, un is the final amount, u naught is the initial amount, e is a constant, r is the interest rate per year, and t is equal to the number of years. Understood? आया क्या ये समझ में? Yes? ठीक है? Okay. So let's see an example of what is happening. अच्छा, पहले मैं इसका एग्जाम्पल ले रहा हूं for continuous compound interest, and then I'm taking for some other examples. So let's take one example from here. Okay. So the question is, in a bank, principal increases continuously at the rate of 5% per year. Find the value of rupees 1000 deposited with this bank. An amount of rupees 1000 is deposited with this bank. How much will it be worth after 10 years? So let me tell you what the question is. This is an example for continuous compound interest. The interest is being compounded continuously and the rate is 5% per year. The initial amount u naught is equal to 1000 rupees. Okay? So I have to find the amount I will have after 10 years. Okay? The interest is being compounded continuously. So I will use this formula un is equal to u naught into e to the power r into t. Here u naught is equal to 1000, r is equal to 5. So this will be equal to 1000 into e to the power. R is not equal to 5, it is equal to r percent. So this will be equal to 0.05 into t. R is in percent. R is in percentage. Okay? 5 mat use kar lena, it will be wrong. R is in percentage. So 0.05 into t. Then at t is equal to 10, un, which is the final amount, un will be equal to 1000 into e to the power 0.05 into 10. This is equal to 1000 into e to the power 0.5. Can you calculate this value? E to the power 0.5 is equal to 1.648. 1.648. So we get this is equal to 1648 rupees. So final amount un is equal to 1648 rupees. क्या ये समझ में आ रहा है? Understood?
Yes, sir.
Yes, Shruti, समझ में आया क्या?
Yes, sir.
Okay, all right. So now, this is the example when we are continuously, when the interest is being compounded continuously. Okay? Take one more example from your book. This is not for continuous compound interest. In the investigation we have, first part of the investigation. Suppose $1,000 is invested for 1 year at a fixed rate of 6% per annum. Use your calculator to find the final amount or maturing value if the interest is paid annually. Okay? This is another example. The formula we'll be using will be un is equal to u naught into 1 plus r by capital N to the power n into t. Okay. So now first part of this is, if the interest is being compounded annually, that means capital N will be equal to 1. Okay. So we get un, which is the final amount, is equal to u naught into 1 plus r, which is equal to 6 upon 100 लिख रहा हूँ, to the power t. क्या ये समझ में आया? Yes, are you able to follow?
Yes, sir.
Okay, so now the second part is, if the amount or the interest is being compounded quarterly, if it is being compounded quarterly, in 1 year I will be getting the interest 4 times. So capital N will be equal to 4. So final amount un will be equal to u naught into 1 plus 6 by 100 into 4 to the power 4t. Third, if it is being compounded, interest is being compounded monthly, in that case n will be equal to 12. Final amount will be equal to u naught into 1 plus 6 by 12 into 100 to the power 12t. If it is being compounded daily, then n will be equal to 365. Final amount will be equal to u naught into 1 plus 6 by 365 into 100 to the power 365t. If it is being compounded by the second, so it will be equal to 365, n will be equal to 365 into 24 into 60 into 60. So un will be equal to u naught into 1 plus 6 upon 365 into 24 into 60 into 60 into 100 to the power, जगह कम पड़ गई, to the power 365 into 24 into 60 into 60 into t. Okay, so by the millisecond you are able to get it. Capital N will be equal to 365 into 24 into 60 into 60 into 1000. un will be equal to u naught into 1 plus 6 upon 365 into 24 into 60 into 60 into 1000 into 100 to the power 365 into 24 into 60 into 60 into 1000 into t. ठीक है, this will be the formula for the final amount. आ गया समझ में?
Yes, sir.
Okay, all right. So now coming back to continuous compound interest. In continuous compound interest, we can understand the concept using calculus as well. Okay? We can use calculus to explain the situation. So, for example, let's take an example to understand how. Suppose in a bank, okay, what happened?
Sorry, sir. So I have to leave early, so I
Huh?
don't know. I have to leave early
Okay, all
right
right.
now. So you can continue with the class. I'll watch the video.
Okay, ठीक है. I think there will be not more than 10 to 15 minutes. So watch it later for sure. Okay.
Yes, sir. Yes, sir. Sure, sir. Okay, sir. Thank you.
All right. So in a bank, if principal amount, let me see, क्या था? हाँ, principal. increases continuously at a rate R% per year. Okay, so the compound interest is being paid continuously. Okay, then find the amount after T years. Okay, so the amount which we have in the bank, okay, it is being compounded every moment, continuously it is being compounded. Then we have to find the amount after T years. So we have to find the formula. So we can write the situation as this: dx, where x is the amount in the account at a time t, dx by dt is equal to r into x. The rate of change of amount dx upon dt, the rate of change of amount is equal to r% of x. It is equal to r% of x. Okay, so we can write dx upon dt is equal to r into x. Then exchanging these values, I can write it as dx upon x is equal to r into dt. This becomes an differential equation. Okay, this becomes a differential equation. So I am solving that differential equation, integrating both the sides. We get, यहाँ पे क्या होगा इसका इंटीग्रेशन? Yes, तुमने पढ़ा हुआ है differentiation and integration in your classes.
Yes, so we did it in 10th.
So integration of dx upon x क्या होगा? Integration of 1 upon x.
क्या sir?
Integration of 1 upon x क्या होगा?
X.
Forgot. अच्छा, integration क्या होता है? किसी को याद है क्या? It is
So I think it's the reversal of derivation.
Yes, it is the reverse process of derivation. ठीक है? तो 1 upon x किसका डेरिवेटिव होता है? क्या ये याद है?
So will it be 1 upon x square?
1 upon x square का? अच्छा, डेरिवेटिव करके देख कितना आ रहा है 1 upon x square का?
अच्छा नहीं
कितना आएगा?
वो तो 2x हो जाएगा ना, minus 2x.
minus 2x.
नहीं minus 1 upon x हो जाएगा ना?
हाँ, तो 1 upon x किसका डेरिवेटिव है? ये याद नहीं है क्या?
So I've forgotten, काफी टाइम हो गया करे हुए.
श्रुति?
So जितना I remember, I think it's 1 upon x square.
I don't know anything. I'm lost.
Anything.
So it's been February and I haven't touched math after that.
नहीं so I haven't done derivation and integration after
math, after our
no
board.
after that I haven't touched this particular topic.
I haven't done math after that. For sure.
I have done math, but I've
तो जब
forgotten
पढ़ना
this.
चाहिए था ऐसे पढ़ना चाहिए था ना कि बाद में भूलो नहीं.
Sorry.
टच मैथ्स को तो आज पढ़ोगे फिर 10 दिन बाद वापस भूल जाओगे, ऐसा थोड़ी होता है. डेरिवेटिव ऑफ log x, डेरिवेटिव ऑफ log x इज इक्वल टू 1 अपॉन x होता है. क्या ये याद आया? ऑफ कोर्स log में अपन यहाँ पे जब डेरिवेटिव लेते हैं बेस इज e. सो इंटीग्रेशन ऑफ 1 अपॉन x इज log of x to the base e. Integration of 1 upon x is log of x to the base e. R is constant here, तो integration से बाहर आ जाएगा. Integration of dt will be t, and there will be a constant of integration c here. So log x to the base e is equal to rt plus c. Now,
So फिर वो 1 upon x will be ln x ना?
yes, this is equal to ln x.
Now I remember.
हाँ. So at t is equal to 0, initial amount will be equal to at t is equal to 0, x is equal to x naught, which is the initial amount. Then this implies यहाँ पे t की वैल्यू 0 हो गई तो r into t 0 हो गया, log of x naught आ जाएगा, log of x naught to the base e is equal to c. This is equal to ln x naught. ठीक है. This implies log of x naught to the base e is equal to rt plus log of, sorry यहाँ पे x naught नहीं है, log of x है. This rt plus log of x naught to the base e. ठीक है, ऊपर कंटिन्यू कर रहा हूं. यहाँ पे इस टर्म को इस तरफ लेके आएंगे लेफ्ट साइड में, लेफ्ट हैंड साइड में. देन log of x to the base e minus log of x naught to the base e आएगा. Using properties of log, we can write it as log of x upon x naught to the base e. करेक्ट? ये प्रॉपर्टी याद आ रही है?
Yes, sir.
Log of a minus log of b is equal to log of a upon b when the base are same. ठीक है? So
yeah,
log
so because minus is a division in the
क्या?
in log. When there's minus, it's divided now, तो फिर उस हिसाब से.
क्या मुझे समझ में नहीं आया. What?
So when it's like ln a minus ln b, it'll be ln a upon b, na? So that identity.
Yeah, that's the property. Yes, ln a upon b can be written as ln a minus ln b. ठीक है? So log of x upon x naught to the base e is equal to rt आ गया. From here, I can write it as x upon x naught is equal to e to the power rt. Using the definition of log, this implies x is equal to x naught into e to the power rt. क्या ये दिख रहा है कुछ? It is similar to the formula, or it is exactly the same formula that we had for continuous compound interval, continuous compound interest. Yes or no?
Can you repeat the question?
क्या श्रुति?
Can you repeat the question?
I'm not able to hear you.
Am I audible now, sir?
Yeah.
Can you repeat the question I'm saying?
This formula, is it similar to the one that we had earlier? Un is equal to u naught into e to the power rt. Yes, it is exactly the same. ठीक है? X is the final amount, x naught is the initial amount.
Yeah, A is replaced with E, that's it.
Sorry?
A,
क्या?
A is replaced with E, that's it.
A कहाँ पे आ गया उसमें?
उसमें A था ना, A to the power, उसमें A था, so it's here it's E.
नहीं, A, अरे यार U और U naught थे ना उसमें से, बाकी सब तो सेम ही है. UN and U naught e to the power rt, यही तो था फॉर्मूला. ठीक है? A की जगह E नहीं आया है, इस वाले एक्सप्रेशन की जगह आया है 1 plus 1 upon a to the power a. इसकी जगह पे E आया है, not in place of A. ठीक है? So here as well we get the same formula, which is the formula for final amount when the interest is compounded continuously. श्रुति क्या हो रहा है?
तो कोई कॉल था, तो मैंने रख दिया. This way I just picked up and I.
तो अभी तो ऐसे ध्यान रख, क्लास में, क्लास पे फोकस कर.
So, sorry.
इधर उधर ध्यान जा रहा है तेरा बहुत. आई नो कि थोड़ा सा देखो अभी अटेंशन में हो सकता है प्रॉब्लम, बट नो जितना ट्राई कर सकती है उतना ट्राई कर. डोंट टेक स्ट्रेस और एनीथिंग. ठीक है? मैं ऐसे ही बोल रहा हूँ ताकि तू फोकस करे क्लास पे.
Sorry, sir, sorry.
So x is equal to x naught into e to the power rt. This is the formula that we get using calculus as well. So we can explain the same thing using calculus as well. ठीक है? I've told you this because तुम लोगों ने calculus पढ़ा हुआ है at a basic level. इतना ज़्यादा नहीं है, but थोड़ा सा पढ़ा हुआ है कि इंटीग्रेशन और डिफरेंशिएशन क्या होता है. कैलकुलस क्या होता है, इसलिए आई हैव टोल्ड यू कि यहाँ से भी ये आ सकता है, ठीक है. अदरवाइज दैट इज ऑल्सो डेरिवेशन जो अपन ने पहले किया था फॉर द सेम थिंग, ठीक है. All right, this is about continuous compound interest. Let's take some examples from your book, from the exercise for natural exponential. So some examples. This is exercise, कौन सी exercise है ये? 2F. Exercise 2F from the book. ठीक है. All right. Do you have the book with you? श्रुति नहीं है? ठीक है. So अच्छे से सुनना है question and try to understand. वैसे तो ज़्यादा मुश्किल नहीं है. I'm taking question 10. It says on the same set of axes, sketch and clearly label the graphs of f of x is equal to e to the power x, g of x is equal to e to the power x minus 2, h of x is equal to e to the power x plus 3. और next वाले question के भी मैं ले रहा हूँ. Y is equal to e to the power y is equal to minus e to the power x and y is equal to 10 minus e to the power x. इन सब के अपन को ग्राफ प्लॉट करने हैं on the same set of axes. So I'm writing down the functions. Y is equal to e to the power x, y is equal to e to the power x minus 2, y is equal to e to the power x plus 3, y is equal to minus e to the power x, and y is equal to which is the last one, 10 minus e to the power x. We have to plot these functions. ठीक है. So e to the power x का ग्राफ कैसा होगा? It will be an increasing function because the base is more than 1. ठीक है. So it will be an increasing function. E is approximately equal to 2.718. So graph of this function will be like this. This is 0, 1, -1 और 1 में दो values ले रहा हूँ for us to be able to plot the graph easily. At 1, the value of the function y is equal to e to the power x will be 2.718. At -1, at x is equal to -1, y will be equal to 1 upon e. 1 upon e की value is approximately 0.36. So at -1, it will be equal to 0.36 approximately. ठीक है. This will be the graph of y is equal to e to the power x. Then next we have to plot the graph of y is equal to e to the power x minus 2. Can you tell me the transformation we'll do here? क्या ट्रांसफॉर्मेशन होगा यहाँ पे? दिव्यानी,
Sir,
yes.
hello. Sir, can you hear me?
Sorry, I'm not able to hear you.
Sir, can you hear me?
Yeah.
Yeah. So because it's e to the power x plus 3, which will affect the value of y.
नहीं, this one.
अच्छा, ऊपर वाला.
e to the power x minus 2. याद आ रहा है क्या?
Also,
Recall karo. If we have y is equal to e to the power x, and we have to find, or we have to make the graph of y is equal to e to the power x minus h or plus h, क्योंकि मैंने plus h बताया था. So it will tell us the horizontal translation. If h is positive,
so
we will
will it
shift
move
it.
towards the left
We will,
side?
if h is positive, we will shift it towards the left side by
Yeah.
h units. If h is negative, we will shift
It'll
it
move
towards the right side
by
by
h
h units.
Yeah.
तो यहाँ पे same type का situation है. H is equal to -2, so it is negative. So we shift the graph opposite, means towards the right side. ठीक है? So we just basically shift the graph horizontally by 2 units. So जो values -1, मतलब जो values यहाँ पे आ रही हैं, same values will come at 2 higher units. So -1 पे जो value आ रही है वो 1 पे value आएगी. 0 पे जो value आ रही है वो 2 पे value आएगी. 1 पे जो value है वो इसके लिए 3 पे value आएगी. So the graph will be like this. The graph will be like this. This is the graph of y is equal to e to the power x minus 2. ठीक है, यहाँ पे वैल्यूज क्या हो जाएंगी? 1, 0.36, 2, 1 and 3, 2.718. क्या ये समझ में आया? We are just basically shifting the graph 2 units to the right side. Now, in the next one, y is equal to e to the power x plus 3. इसमें क्या होगा? We are taking from this. Y is equal to e to the power x के में
So it'll be a vertical shift.
vertical shift by 3 units. ठीक है?
Yeah,
Upwards.
3 units upwards. Yeah.
Upwards, yes. So इस ग्राफ को अपन 3 units ऊपर शिफ्ट कर देंगे. तो -1 पे जो वैल्यू आ रही है उसमें 3 ऐड हो जाएगा. 0 पे जो वैल्यू आ रही है उस पे 3 ऐड हो जाएगा. इस पे जो वैल्यू आ रही है उस पे 3 ऐड हो जाएगा. And the horizontal asymptote will be equal to y is equal to 3. बस 2 मिनट और and I will leave you. श्रुति, इतना एकदम एग्जैक्ट छोड़ने की भी जरूरत नहीं है मुझे. ठीक है? So now, सॉरी मैंने थोड़ा सा ऊपर ले लिया इसको. यहाँ पे this is y is equal to 3. So at -1 the value will be equal to, at -1 the value will be equal to 3.36. At 0 the value will be equal to, value of the function will be equal to 0, 4, and at 1 it will be 1, 5.718. So the graph will be like this. Like this. समझ में आ रहा है? Yes, able to recall these things?
Yes, so now I've recalled, like I recalled all of them.
Yeah, you guys are not practicing, इसलिए इतना जल्दी याद नहीं आ रहा है. Only when I tell you are you able to recall them. So start practicing. ठीक है? ऐसे miss मत करो ये चीजें. Then next graph, y is equal to -e to the power x. So the function is getting multiplied by a negative sign.
Negative, yeah.
तो क्या होता है? We get a reflection with respect to the x-axis. This is the x-axis.
So वो बस पूरा graph reflect हो जाएगा ना, जो like positive values will become negative and negative values will become positive.
हाँ. So positive ही है सारी values, तो सिर्फ नीचे आएगी, सारी negative हो जाएंगी values. तो -1 पे the value will be minus 0.36. At 0 it will be minus 1, and at 1 it will be थोड़ा ज़्यादा नीचे ले लिया। एकदम रिफ्लेक्शन बनेगा एकदम। At 1 it will be minus 2.718. So this will be the graph. I'm making by hand, so it might not be completely accurate. I'm trying my best to make it as accurate as possible. ठीक है, ऐसा ग्राफ बनेगा. This will be the graph of y is equal to minus e to the power x. This is the graph of y is equal to e to the power x plus 3. Now next one, y is equal to 10 minus e to the power x. ठीक है, अब यहाँ पे क्या होगा इस ग्राफ में, अब यहाँ पे इस ग्राफ में देखेंगे, this graph will be shifted by 10 units upwards, vertical shift. आ रहा है क्या समझ में? इस फंक्शन में 10 अपन ऐड कर रहे हैं पूरे फंक्शन में, तो the graph will be shifted vertically upwards by 10 units. So now y is equal to 10. y is equal to 10 जगह नहीं है तो मैं विदाउट स्केल बना रहा हूं. Y is equal to 10 will be the horizontal asymptote. So y is equal to 10. ठीक है, same graph will be shifted upwards. So the value at minus 1 will be minus 0.36 plus 10. Minus 0.36 plus 10, which is equal to 9 point कितना हुआ 9.64 हुआ क्या 9.64 plus 0.36 will be 10, correct. Then this value will be 0,9. Again this is not by scale. ठीक है, जगह नहीं है इसलिए मैं स्केल के अकॉर्डिंग नहीं बना रहा हूँ ये वाला इस फंक्शन का. And this one will be 1, 10 minus 2.718. 10 minus 2.718 will be approximately 7 point कितना हो जाएगा 2 8 1 2. ठीक है, this will be the value. क्या ये सही है एकदम? ऐड करेंगे तो yes सही है. Okay, so this will be the value. इनको मैं ज्वाइन कर दूंगा by free hand. This will be the graph. अभी exactly सही से नहीं बनाइए थोड़ा. क्या समझ में आ रहा है? अरे बोलो कुछ.
Yes, sir.
So this will be the graph of y is equal to 10 minus e to the power x. This is the graph. This graph will be shifted by 10 units upwards.
I actually don't know all of this.
Sorry?
I actually don't know all of this because I missed the transformation class.
You don't remember all of this?
No, I missed the class.
अच्छा, तो transformation is important, so try to see the video again, ठीक है, for transformation of graph.
I have to, yeah. So how many chapters have we done? We've done functions and transformations. That's it, right?
We have done what?
How many chapters have we done?
In
In tuition.
exponential function.
No, in tuition, right here.
In total,
Yeah.
we have done 13 classes.
No, chapters.
Chapters. We are done with 3 chapters today.
Oh, we're done with 3 chapters. Oh, shit.
Yes.
I haven't practiced any. I'll start.
We have
we've
done sets and Venn diagrams, we have done functions, and we have done exponential functions.
Okay, sir. I'll
And
have
we won't take much time for logarithms also.
Okay, sir.
ठीक है? Yeah.
So बस इतना ही है आज.
Sorry?
So only this much today.
Yeah, this is
Okay.
all that we are doing today. I want you to take a few more examples. But ठीक है, आज छोड़
Sir
दे.
was going to leave us at 6:50.
Yes, yes,
He took
ठीक है.
10 extra minutes.
नहीं ले रहा हूँ मैं आगे, ठीक है. And you have to do this, but you have to do this exercise and come to the next class.
Okay.
Prepared.
So
ऐसा नहीं होना चाहिए कि आज भी नहीं किया मैंने. Try to do these questions. ठीक है?
okay. So
Complete the
thank
chapter
you.
from the book.
Thank you, sir.
Thank you,
Bye,
sir.
sir.
Okay.
Bye, sir.
Okay. Bye bye.